Good afternoon and welcome everyone. This is Mark Henry with Opmantic. I'm a senior engineer here in Opmantic's North American office located in Charlotte, North Carolina. Today we're going to talk about how to effectively design and build a single pane of glass using Opmantic's OP Charts dashboarding system. As a reminder, we're going to put everyone on mute during the presentation just to keep out any background feedback, background noise. If you have a question, you can use the chat window, the GoToMeeting chat window, to ask it, or we're going to be opening the floor after the presentation, and you can unmute yourselves and ask any questions at that point as well. So there are really three topics for today's session. The first, the most important really is why use a targeted or user-centric dashboard design? What's the importance of it? Why go that route? The second piece that we're going to talk about is how much information you should have on any kind of a single pane of glass or a dashboard. Generally speaking, less is better than more. And the third piece that we're going to talk about is how to create a layered dashboard that goes from a very abstract or 50,000 foot level down to the root cause of an issue very, very quickly. And that's really the entire point of having a single pane of glass, is the ability to have those very, very high or almost management level dashboards that show more of the entire organization's infrastructure and health, and then be able to go from that level very, very quickly down to individual devices, problem interfaces, circuits, etc., and understand that flow. So let's talk for a minute about what a single pane of glass is, and I think more importantly, what it really isn't, right? The concept of a single pane of glass, and this acronym has been around now in the IT industry for the last 8 or 10 years or so. It's almost the holy grail of user experience and interface design today. And you'll hear it through almost every different type of software product that's out there. Manufacturers offer products with single panes of glass. But really, when it comes down to network and device monitoring, service monitoring, a single pane of glass is about taking together disparate sources of data, being able to bring them together into one interface that provides really actionable insights in the sense of a bigger picture. You'll often hear the term single pane of glass. It's a synonym for dashboard. So here at Opmantic, we use the term dashboard, and really it's the same thing. We use it interchangeably with single pane of glass. A single pane of glass or a dashboard really has three pieces that are required to make it effective. The first part is it has to have a really thoughtfully laid out user interface, right? So you have to give thought to the different information that you're presenting. It has to have some kind of a logical structure behind it so that the information relates together and shares some kind of a cohesive bond. And the third piece is that it really has to be customized. We often hear clients ask us, do you have pre-built dashboards? And almost every network monitoring tool has something that's pre-made, but a really well-crafted system that will provide what we consider a single pane of glass allows you to build targeted, customized dashboards that meet the needs of the end user. So depending on the role of the end user, you might have someone who answers phones in a call center, and they handle very specific, perhaps layer 1 or tier 1, level 1 customer support. And they have to have very specific dashboards which speak to the types of questions people would pick up a phone and call in on. You might have different dashboards focused on your database administrators or on your server engineering team versus your network engineering team. And so being able to create customized dashboards that speak to those specific roles and responsibilities is vital to produce a really vibrant single pane of glass. So there are many benefits that come with a single pane of glass when it comes to network monitoring. We've chosen three as kind of our top tier pieces. The first of it is giving you increased visibility. The concept that you're not isolated in most user interfaces to one specific product or type of equipment or role of equipment or location of equipment. You want to be able to expand your visibility across all types of equipment, both networking and server-based pieces of equipment, circuits and interfaces, and bring that kind of information together in a way that makes sense for the people who are going to be viewing it. You also want to reduce your operational complexity. So rather than necessarily having 5, 10, 15 point solutions for different manufacturers or models of equipment, that you can bring that information together under one unified user experience to reduce that requirement. So engineers aren't logging into different applications, bouncing around through different things. They've got dozens of tabs open or dozens of applications on their desktop. And the final, and as a network engineer myself, that one item that I consider kind of my number one piece is reducing time to root cause analysis. The concept that when something breaks in my network, I need to be able to see it very, very quickly as an error, as something that's gone wrong, and then be able to go from that kind of a 50,000 foot view and dive down very, very quickly, traversing layers of detail and getting immediately down to whether it's a server with a memory overload, an interface that is bandwidth constrained perhaps, or has a high number of errors and discards because that router perhaps has high CPU usage right at the moment, or perhaps a high temperature physically because of where it's located, and being able to ID and understand what that cause of that problem is very, very quickly so that we can put a fix in place, right? That's the piece. That's really the goal at the end of the day from an engineering perspective, is to identify that problem and then be able to roll out a fix as quickly as possible. Excuse me. So when it comes to the concept of a single pane of glass or kind of a cohesive dashboarding system, I'm often asked, well, what does it mean? How do I actually, can you show me something? Can you tell me what that means to me and what it returns to me? So what I'd like to do is share a couple of case studies that we've had. The first one is just on a wireless ISP. So this is a regional internet service provider. They're using gigabit wireless systems. In this case, they happen to be Radwin equipment. We had a bit of a challenge with them. They were buying some really cutting edge devices, getting some new pieces out in the field, getting them working. And even the manufacturer didn't really have a monitoring solution in place yet because the equipment was too brand new. It was almost in a beta test state at that point. We worked with the client. We modeled those devices very quickly using SNMP. We modeled them in our performance management solution. We're able to bring that information into our system, create fault monitoring and thresholding based on that. But more importantly, and it's kind of shown in the bottom right-hand corner, we also work directly with that ISP's NOC center. So all of their engineers, their help desk team, their phone team, but also the engineers who were responsible for the day-to-day operations of their systems, worked with them on the design of custom dashboards for each of those roles. And we'll talk a bit more in a few minutes about how to design those dashboards. But we worked on dashboard design for them. And again, a dashboard is synonymous with a single pane of glass. We were able to work on custom dashboards for them. We were able to help them retire 4 other network monitoring solutions, including a handful of very pointed solutions that were manufacturer model number specific. They were able to set those aside and focus in on these custom dashboards, and just doing a quick analysis before the rollout and then after the rollout on how long it took them to be able to see a problem, identify the cause of the problem, and then understand what the root cause was and how to address that. So we did a bit of analysis up front. We did an analysis post-implementation, and then ongoing about 4 months after implementation. And we determined that based on the implementations of those dashboards, with the original ones we built for them, and then ones that they continued to build and upgrade and maintain themselves as they absorbed our solution set more fully within their process, they reduced their analysis time by 65%. And that's tremendous. That's a massive, massive improvement. So just think about it. If you're looking at an hour of time, let's say from time 0 to time 60 minutes in, using their old process. If you reduce that by 65%, you're taking that from 60 minutes and you're cutting it all the way down to about 14 at that point. So it was a massive reduction in their time to figure out what was going on, what was happening, and then what they needed to do to be able to mitigate that problem or fix that problem. Slightly different position here. This one happens to be a rather large international communications company. This company does a lot of TV stations, radio, newspaper, magazines, etc., located across multiple continents. We helped them design a system that scaled horizontally and vertically. So they had polling servers out in the field monitoring their data centers and also monitoring their various offices throughout the world. And then above that, we had a series of master servers that received performance and fault information from those. Again, working with their team very, very closely, understanding their breakdown of roles and responsibilities across their infrastructure. So they were very much a siloed operation where you had groups responsible for internet service providers, for internet connectivity, but also a separate group responsible for networking equipment and another group responsible for server equipment. And then also different groups in different geographical regions for Western Europe, for the US, the Western US, and then also for Asia. And so working with those teams, what we did was, again, understand their processes, their roles or responsibilities, and then design series of very targeted dashboards, again, that provided a very high-level abstract view of their entire network. And it gave them a view that they hadn't had before. In previous incarnations, each different team, the networking team had a set of tools, and all they could see was networking equipment. The server teams had different tools for Linux machines and for Windows servers, and those two teams didn't share their tools, didn't share their information, and as a result, the two teams were often throwing responsibility or problems back and forth. No, it's not the network team, it's something with the servers. No, it's not the servers, it's something to do with the network infrastructure, or something to do with the bandwidth and the interfaces. And by bringing all of that together in dashboards that provided that single holistic view of the organization, of applications and services, of servers and networking equipment, by pulling that all together under a series of multi-tiered dashboards, their teams are very, very enabled at this point to go from that high 50,000 foot view where they're seeing more about application and user experience, and then understanding that user experience in a one geographic location has been affected, and then drill down into that location into a hardware perspective and understand where the problems are. Is it an internet connection? Is it a router that's gone bad? Is it a server that's slowed down and overloaded? So we've talked for a few minutes about the concept of what a single pane of glass is. The top three outputs from those types of things. We talked about what kind of return on your investment you can see through the different case studies we shared. Now let's talk about the amount of data that you should be sharing with these. There are many different products out in the marketplace today that claim to have a single pane of glass, but in many cases, they're simply taking a lot of information, shoving it into some very, very pretty graphs, and then putting it on the screen, and then hoping that users will pick and choose and figure out which ones are important and which ones to pay attention to. It has been our experience, and it's been the experience of researchers, that there's really a limit to the amount of information that an individual operator can take into when they're looking at any one individual screen of information. And so from our perspective, we've come up with a series of 7 rules, really. And so, again, these are more rules of thumb necessarily than hard and fast must-haves. Generally speaking, we recommend to users that any dashboard or single pane of glass contain no more than 5 to 7 groups of data. And we'll show an example of what Augmentech considers a group in just a minute. Each group layout should be organized by the data types, the time period, or the visualization, meaning that when you start putting things together on the screen, you want like things to be next to like things. You want the relative time periods that each chart or graph covers to be similar, or at least organized in a way that makes sense. You want to make sure that no individual group has more than 5 to 7 data sets. And you'll see that number range, 5 to 7, used quite often. It tends to be the more complex the information, the fewer numbers you want. So you want to be closer to the 5. And the more abstracted that you can be, higher towards the 7. You want to make sure in designing your dashboards that each data set is easily distinguishable from other data sets in the group. So if you have a group that has 10 data points or 10 data sets within it, you don't want them all to be blue, because then it becomes very, very difficult for users to understand which of those lines in a chart, for example, represents which different data point. Number 5, you want to make sure that data sets across groups should use similar colors and icons. So if you're tracking the same thing, let's say errors and discards, and you draw it in red on one chart, you wouldn't want to draw it in blue on a different chart. So try to keep your colors consistent in how they're used. Colors and shapes should be used with purpose and definition. This should go without saying, but you don't want to necessarily have mystery meat dashboards. And finally, the entire dashboard should be visible at one time, as should each group. So you want to try to avoid scrolling, if at all possible, in your dashboard designs. This can't always be avoided. Sometimes certain dashboards, it just makes more sense to put more information on it. It really depends on how the users are going to interact with it. If you're in a Knox Center where a dashboard is being projected onto a big screen, you certainly don't want someone to have to scroll around in that. You want everything to appear in just one organized window of information, and be able to see everything that's there, and then be able to drill from that down into more detail. If a dashboard is designed for a single operator to sit at their desk, work on their monitor, certainly if it makes more sense to create a scrolling dashboard, you can do that. Although, again, it's really not recommended. You don't want operators to miss something because they've minimized a window or shrunk a window down smaller than full screen and didn't notice that there were scroll bars. So let's take a moment here and take a look at an example of an overly architected dashboard. This was built with Augmantic's OP Charts tool, just to give us an example here in this tool. And again, any dashboarding system that you can build out a single pane of glass holds the opportunity for building something bad. So let's take a few look at this. So in this example, each of these panes, each of these little windows that are drawn here. So for example, this one in this corner, and then you have one here, and you have a third one here. Each of these are what we consider a group of information. Some people may refer to them as widgets, or bricks, or informational panels, however you want to call them. This one happens to have, or this dashboard happens to have 9 within it in all. So again, the kind of rule of thumb is 5 to 7 in all. So there are too many groups in use. There's also poor grouping. So a good example of that might be taking a look at these two pieces down here, which seem to show some kind of service response, and then there's another service response in this top center piece as well. So we haven't really grouped these together. And then there's suddenly a CBQoS stack and a topology map and a few other pieces that are going on here as well. Too many data sets. So we talked about the concept of having between 5 and 7 data sets. This CBQoS stack, I believe, has 9 different data sets built into this, and that's why it seems a little busy down here with all the different colors that are stacking up. There are also ones that are too similar. So I gave this example a moment ago about poor grouping, but you'll notice that all 3 of these are drawing in gold or dark yellow. And even though they all do represent some kind of a service response time, so in one way, they are similar in the types of data. They are 3 different service responses, and perhaps rather than drawing them all in the exact same color, it might be better to do them in different colors, but also group them closer together physically. We talked about the concept of making everything fit. Now this map in the top left corner doesn't have scroll bars, which is good, but then you can see that the icons don't really fit, and there may be other icons on this map that aren't available either. All three of these panels suffer from the same challenge. They all require some kind of scrolling. You can see there are vertical scroll bars on the two panels on the far right, the top end CPU and the top end memory. And then in the monitored services list, there's both a horizontal and a vertical scroll bar. So those are the kind of base rules that Aumantic teaches when we do implementation and operator training. So if those types of things are the rules that we have to stay within, how do we design a dashboard for a single pane of glass? How do we actually create something? So we like to take a minimum of a 3-level view. In many cases, we'll go as far as a 4-level approach, although those are generally not the rule. They're the exception. So we often start with the concept of an abstract dashboard. And that might be a topological map. It might be a map of a service that shows the cluster of backend databases, your application servers, your web server on the front end, maybe any load balancers, your switches, your routers, your internet interfaces laid out in a way where an operator can come to that high-level abstract dashboard and understand these things are working, these things are going okay, or something's happening, and then they can drill in further. So we start from that concept, that 50,000-foot view here with some kind of a logical map. And again, it could be topological, it could be a network map. Our systems, OP Charts, supports the concept of taking a Visio diagram or taking any kind of a graphic as a background image and then overlaying status of devices or groups of devices on top of that. So starting with something abstract and then allowing the user to interact and drill down into something more detailed. In many cases, that takes one of two formats, either some kind of a network or topological diagram or a list of services and understanding what those services are and the health of those services. And finally, the last layer, as you're kind of starting from the 50,000-foot view. So if this is 50K, then we're kind of coming down to 20, and then you're down in the weeds. So there you go, weeds. Don't knock me on my drawing capability. It's the best I can do. Things to remember, to keep in mind for effective dashboard design. Dashboards require some kind of a graphical interface that is laid out and easy to navigate. And we're going to get to that in a minute. I'm actually going to build one with you and give you an example. And it needs to have a logical structure behind the display that makes accessing current data easy and fast. So let's switch over now. I'm going to leave my PowerPoint presentation here and head on over to a live view. Now you may remember this. This is our bad dashboard design. Now I could start with this and move pieces around, remove pieces, and clean this up a bit. In fact, we could go ahead and do that. But what I'm going to do instead is I'm going to make a new dashboard. I'm going to create a new dashboard. So very quickly. What I'm going to create is I'm going to create that first top level or high level dashboard. The concept that we want to have something that can be shown on the screen primarily and that people can kind of keep track of what's happening. So I'm going to add a couple of components to this. In fact, I'm going to add a second component, and then we're going to go ahead and assign what these are. So what I'd like to be able to do is create a simple dashboard that operators can look at and very, very quickly understand what the overall health of their system is, right? From a very, very high level point. So I'm going to do two different maps. So I'm going to do a Charlotte map, and we're going to do a Charlotte topological map. So we're going to look at the world from both a geographic standpoint and also from a logical topological standpoint. So I'm just going to give this a name of top level. And I just gave it that underscore in the name, just so that it'll appear in my list of maps at the top level. So now I've got a geographic map here on the left, and this can be as deep as you want to go. It can be as large as you want to go. You can see through the zoom lock that I can come in to the map, and I can also go out from the map as far as we want to go with that. All right. So I have a first dashboard here. What I'd like to do next is I want to be able to go from this very, very top level very, very quickly down. And I can do that already. So each of these icons, and this map happens to have a couple of them on it. So you can see that this represents just one piece of equipment. This happens to be a Cisco router. Whereas this icon here at the US Operations Center represents a few more. And we can drill into that. So now what I'm doing is I'm going from 50,000 feet. I'm down at that 20,000 foot level. So in this case, I just happen to have one device. And I can drill right into that. And now I'm very much in the weeds at this point, and I'm wondering, why is this device listed as degraded? Why does it have that yellow background? And I can see on the left-hand side that it's yellow, that it's degraded, because this happens to be a virtual machine host, and there are several machines that are not powered up. Now, with Augmantic solutions, you can pick and choose which thresholds, which types of errors and events affect icon coloring, notifications, emailing, SMS text messages, all of that type of notification type system. So now that I've built a top level map, I want to have a middle level map. I want to have something from that, between that top level map and this detailed piece that gives me maybe a slightly different view, something more informative for me. So let me quickly create a dashboard in the middle tier. Now, from my perspective, there are a couple of different ways that I might want to go with this. At that middle tier, if we go back to PowerPoint for just a moment, at that middle tier, generally speaking, we talk about the concept of using either something like a network diagram or a list of services. So again, you're starting at a top level, you're trying to get a feel for what's happening at a large geographical or logical footprint. And then at that middle tier, you're looking at either a physical regional area, a smaller listing of devices, or you're focusing in more on services. So what I'd like to do in this example, I'm going to create a list of services. So I've created previously a list of business services for me here. So I've got demo, and we're going to go ahead and save this. I'm just going to call this mid-level. All right. So you can see here, I still have a little bit of scrolling going on. There's a lot of things in this business service list. So I can actually expand this if I wanted to. I can stretch this out. We can also send this to full screen if we need to. So that gives us another view here. All right. Let's find our top level dashboard. And let's just provide that connection between the top level and the middle level. So I'm going to edit this dashboard. And what I really want to edit is I want to edit this map, this Charlotte map. All right. And so what I want to edit is I want to edit this guy. I'm going to right click on him. And again, the concept is how quickly can you create these and how well do they work? So I can actually send this to a specific map if I want to, or to a custom link in this example. So I'm going to use a custom link. And let me get that link. So I want this URL. That's what I'm going to want to get. And I can do this kind of link in this solution that goes to any kind of a URL. So it doesn't matter, it doesn't necessarily have to be an OP Charts link. It could be linking out to another product entirely. All right. Now we're going to save that map. All right. And it's not wanting to let me save. One of the greatest things in the world is being able to do a demo and have the demo not quite work well for you. So you'll notice here now when we hover, we have a link at the bottom for the mid-level map. And we can follow that link down. And that sends us to our monitor service. And of course, following my no scrolling, we'll want to make this slightly larger as well so that we don't have that pesky scroll window there. And from here, of course, I can continue to drill down into any of these, looking at any of the monitored services, any of the interfaces that are involved, and being able to understand how these are working and how well they're performing or not performing. All right. And that concludes our presentation for today on the rules for developing a single pane of glass or dashboarding system for networking and server monitoring. I'm going to stop recording now and turn on everyone's microphone. So if you have any questions, you can feel free to ask.